All right, there we go. All right, we're gonna do neat code. Wait, I forgot to change the fuck. Oh no, I didn't. Yes, I didn't forget. Yeah, okay. New. Oh wait. This needs to be a Python directory. Wait, yes. New Python directory tests. No Python directory. No directory. Nope. No Python directory. Wait, what? That's not supposed to be happening. I don't really care about this. Actually, we'll leave it. What's the wait? If it's not in, JetBrains, disable. JetBrains autocomplete. How do I disable this? I don't want that. Well, not like I don't. That that's irritating. I need to not have that. It defeats the entire purpose of like what I'm doing. This is supposed to be disabled. I could uninstall it. I wonder if I uninstall it, will it work? This is not installed, so I don't have the AI assist from JetBrains, and I don't have Copilot here. So why is the autocomplete doing that? I don't want autocomplete. Autocomplete should not be autocompleting functions. Like that's so weird. Full line code complete. That's what it is. Suggestions are how does this work? Designed to supercharge. This is Disable. Does that disable all autocomplete? Holy shit. There we go. Let's double check to see whether or not autocomplete works at all. From JSON import. Okay, so autocomplete still works. Okay, there we go. Full line autocomplete is like all I cared about. Like I actually used Copilot for full line autocomplete. Wow. Okay. To be fair, Copilot's like a little bit nicer for that. So all we're doing is we're just gonna make sure that it actually works. That our like we can run tests. Add. Ugh. Wow, apparently I can't type today. I kind of miss it. Python unit test. What was the import? Okay. Yeah. From unit test import test case. Class. Is it? Yeah. Okay. Test. Test. I can never remember which side is which. There we go. That's all I wanted. Okay. That's Leetcode. We want neat code. There we go. All right. For now. Okay, so we have a get. Oh, this is just like straight up a, yeah, okay. So let's see. Okay, so get requires that we return an int. Um, set returns nothing. Why are we doing that? Return, 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 return. Oops. Return. Yeah. So return 0, 0. No, this returns nothing. This returns return 0. Return 0, and return 0. There we go. So let's read what we're supposed to do here. Design a dynamic array, aka a resizable array class, such as an array list in Java or a vector in C++. Your dynamic array class should support the following operations. Dynamic array int will initialize an empty array with the capacity of capacity, where capacity is greater than 0. Get will return. This is so bad in Python. Like this is like actually hard to implement in Python just because like it's just an array. I'm like a little bit confused on like what exactly we're gonna be doing here. I feel like I should go for it. Like this is an easy one. Let's go for a harder one. Singly linked list. Singly linked list. That's pretty easy too. Double-ended queue. Let's see here. Design a double-ended queue class. Yeah, your DQ class should DQ class should support the following operations. DQ will initialize an empty queue. Bool is empty will return whether the queue is empty or not. Void append will insert value at the end of the queue. Void append left will insert value at the beginning of the queue. Pop will remove the return value at the end of the queue. Okay. If this queue is empty, return -1. Pop left will remove the return value at the beginning of the queue. Okay. You should implement each operation in O1 time complexity. Sure. DQ. All right, let's rename stuff. Rename DQ. What's going on here? Oh, I spelled case wrong. There we go. All right, let's get back to here. Who will initialize this? That's not what we wanted here. Want this. Oops. Actually, what we can do here, this will make it easier here. There, beautiful. Now now we have all this data here. We can do this. Append. Append left. Up. Up left. I can't say that actually I guess I have, right? It's been a long time though. Okay, so what we'll do is we'll just pass on all of these. Oops. Here we go. And one more. There we go. Beautiful. Okay. So we need to make effectively a list, right? But we want a queue. Why the fuck am I making a queue? We have a queue, right? Like, problem is that some of this is like actually hard to make in Python just because of the way Python like gives you so much, right? But let's just make this in a list, right? And they want what? O of one time complexity. Interesting. Okay. So we need a list, right? So we're gonna do Q. That's not it. My this would be DQ. This would be Q. There we go. Is empty. We'll do return self dot q dot length. No, it's length 0. We'll insert value at the end of the queue. Q dot dot push value. No, it's append. Sorry. Okay, append left will insert the value at the beginning of the queue. That's an interesting one. Python list. That's never where I want to go. Insert. Inserts an item at the given position. The first argument is the index of the element before which to insert. So inserts at the front of the list. Okay. So here, right, we want to test whether or not the queue actually appends, and we want to test whether or not the queue returns back the correct data, right? So we already know that we'll initialize it, right? Setup. And then this will be queue or DQ. D is self dot DQ equals DQ. Def test DQ is empty works. Returns true when queue is empty. Self dot assert true. Self dot DQ dot is empty. Then if we run this, we'll get an error. Oh yeah. Pass. There we go. Wait, what? Did I misspell that? What the fuck? Oh, that's why. Oh man, so good. Okay. Yeah, there we go. Wait, why did that not debug? Oh, that's why it's an append. I did it in append. I didn't mean to do it there. Here we go, debug. Fuck. I feel stupid. There we go. 1, 0, Q. Beautiful. Okay, so we can stop that. Here we go. DQ is and 1. Do this. We say 10. right? And then we do self.dq dot q, and then we do we'll do the first, which should be 1, and oops. Did I accidentally hit capital? No. What? That was weird. Yeah, that's fucking weird. 1, and this should be 10. There we go. Beautiful. We're gonna also do this. Equals. And then we just do this. Right. And then we can rerun it. Use ID shortcut. There we go. That was not correct. Oh. Shift F10. Control F5. Interesting. Oh, that's yeah, no, that's not it. Control F5? Wait, what? Shift 10. Control F5. Oh, wait, debug is Alt F5, right? No, Control F5. Interesting. Run Alt 4. Do Alt 4 and then Control F5. Yeah, Control F5. Oh, so it's all like where I'm doing it, right? Okay, so what we're gonna do is we're gonna do this, right? And then we're gonna do that, and then we'll do, and this is Alt 5, right? So Alt 5, and then we'll do Control F5, and then we're gonna get stuck right here, right? And here we can come into the DQ, and we can see that Q there, this should work, right? But it's because I did this wrong, and that's why it was not working. And then we come over to here and we do Alt 4 and Control F5. There we go. Beautiful. There we go. Amazing. Super, super duper amazing. Okay, so there we go. Let's also do this. Is empty false when Q is not empty. So we're going to do this, and we're going to do assert false. And then we're just going to run all of these tests. Beautiful. Okay, there we go. Def test pop removes and returns the value at the, oh, sorry, no, we need append left. Append left adds value to start of the queue. Dot append left 1 self.dq.append left 10 self dot, yeah, effectively we're doing this but in reverse here. So this should be 10 and this should be 1. 10 and 1. There we go. And then if we do Control F5, we should get an error. We should get it failed. There we go. Beautiful. There's nothing in there, right? So this would be self dot q dot what was it? It was insert, insert, 0 value. And then if we rerun this now, Control F5, we get past. There we go. Now this is actually worth doing if we're doing if we're doing this in C++. This can actually be worth it because like there's actually checks and like if you're doing this in C and C++, it actually makes it worth it. But if you're not, it's kind of not worth doing this. Just not even gonna lie. I think here we should actually just do self.count equals 0 or length. And then here we do length, and then this would be int, right? And then append, right? Here we would do self.length plus equals, or I don't think Python has plus plus, right? Yeah. But Python does have plus equals 1, right? Append left, right? Then pop, we're going to do minus. Oops. And pop left will also do minus. And then instead of doing this is like going through everything again. And really what we want is self.length. Here we go. Oops. Yeah. There we go. Dot length equals 0. Here we go. Those two work now. Beautiful. Add value to start of queue. This also works. Let's also make sure self.assert false. Self.deque is empty. We're just gonna pop that onto all of these here just to make sure. Here we go, and then Control F5. We're only checking this to make sure that our count is actually working because this is the proper for that. So now what we need to do is we need to pop from we'll remove the value at the end of the queue, right? And if I'm not mistaken, if we come down to here and we do pop, remove an item at a given position in the list and return it. If no index is specified, pop removes and returns the last item in the list. Yeah. Remove the first item from the list. Value is equal to X. Here we go. So, if I'm not mistaken, right? Return 0. Return 0. Here we go. Beautiful. Okay, so if I'm not mistaken, right? This should be 0 indexed. Well, actually, I shouldn't say it should be 0 indexed. It is 0 indexed, right? So if I do pop at, like just this pop here, this is all, no, there's really no way for me to not do it, right? Like it's just what it is, right? So return self dot q dot pop. And then here we do self dot q dot remove. What's the problem? Wait, there is a... that's what it was. So here we have to do if self dot length is equal to 0, return -1, else, so I should say is greater than 0. And then in here, because this one we're expecting to hit more often, we would want to do it first, right? We would do that, and then we would return this, and then else, right? We would return return -1, right? And then that can be like that. There we go. Here we go. And this is going to complain a little bit, but like it's not actually valid because you can't get to this unless there's an item in the list, right? Removes the first item from the list whose value is equal. Oh, is equal to. Right. Never mind. So this is just pop 0. There we go. Actually, what happens if we pop 0 on oh, index error. Okay. I was going to say, what happens if we pop on something that doesn't exist? Okay, so now pop So pop takes from the will remove and return at the end of the queue and left, right? So if we do a self dot assert equal, right? Self dot dequeue dot pop should return 1, right? And then we should still have a value here. And then self dot assert equal. We're going to actually do append. We're just going to do append. Append 10, append 1, append 13. Fine. All right, so pop left should be 13, then 10, then 1. And is empty should be true. But we're going to do that first. And then this should be true. We ran 5 tests and all 5 passed. There we go. And then we're going to do the same here, but this is going to be pop left. There, that means that this one should be the first, and then the middle, and then we do the check again. And then if we do control F5, we get all 6. Beautiful. And there's probably a way to like, quote unquote, do this better, right? But at the end of the day, this works, right? And you would never want to do this in a situation where What? Oh, this is using a different version of Python. Let's just close that. I guess. Wait, I guess pop changed, eh? Oh, because we're popping from an empty list. Yeah, okay, that makes sense. Yeah. That's my bad. I did not see that. If self dot length is greater than 0, we do this, and then else return -1. I also forgot to actually test from that there. There we go. So we're just going to do this. And this should be true. And then we do pop left, yeah. And this should be -1. Then we're going to do this exact same thing here. I want to actually move this down because I like to have them in that order specifically. And then this is going to be pop. Control F5. There we go. 8 tests. Beautiful. Submit. Let's see some of the solutions. Yeah, I guess that does make sense, right? But like, I don't know, it's just wasteful. Like we're only dealing with integers, right? You gave me a hard requirement here and I just did the thing, right? But yeah, I guess this would make sense because then we can like jump around. But like this requires so much extra overhead for something that's just acting like a list, right? Yeah. So this is a linked list, a doubly linked list, which does make sense. Let's rewrite it as a doubly linked list, right? Sure. I haven't done a doubly linked like I haven't actually written a doubly linked list in so long, right? Okay, so let's see. A doubly linked list means we've got a link back to the first element and the last element, right? And then the next element. So that is what a doubly linked list is, right? Double, double, doubly linked list. A linked list, a linked data structure that consists of a set of sequential linked records called nodes. So it's got a link to the first link, the first and the first, the last. Oh no, wait. It's got a yeah. Next, previous, reference to data. Okay, yeah. So next will be node. How do I spell previous? Previous. Go previous. Let's take a quick look at this really fast. Yeah, okay. Yeah. I see what they're doing. Def init dot next node. This needs to take in a previous node, right? Wait, what? Oh yeah, just capital N. In so long. Apparently, like I've forgotten how to write Python a little bit here. Equals none. Here we go. Self dot previous equals none. Wait, they had one more value there. What was it? Oh yeah. The actual value itself, and that's an int. Self dot value int equals def get previous, right? Self. Return self dot previous. Def get next. Return self dot next node. Def get value. Return self dot value. There's our length is empty. We can still keep that, right? But we've got the node. We don't want to actually add anything to the node. Because if we add nothing to the node, right, then it is going to be none, right? So if I do, if I do this, q equals none, right? Then we're fine, right? And then we can say, hey, if Q is none, return self dot Q equals none. There, right? And this can be simplified. Is none. There. Then here, instead of an append, right? So we want to add to the end. So we also want to do here. We want to do Q. We want to do last node, first, last and first. There we go. So we want to keep those, right? So is empty. And we want to do last, first equals none. We don't need this anymore. So is empty. Self.q is none. Here we go. Is empty. This still returns true. So if I go like this and we run this, we get we should get this one should be running. Oh yeah. This needs that. There we go. Control F5. Actually, I guess because this, okay, so this builds off of Leetcode skills. It builds off of this one. So why don't we just do this? Right? And then a doubly linked list is just this on steroids, right? So let's do this one first. New file. Singly linked list. There we go. This needs to be renamed. Name. There we go. Okay, so singly list, linked list, right? Beautiful. There we go. Like this. Okay, so class node, right? And then value. These are ints. And then next node is node, right? There we go. But we can't actually put that, so we just do this. And what we actually want to do is we want to do a def init. And then like ideally we want to actually have like an args and a cargs and all of that, right? So linked list, this will initialize an empty linked list, blah, blah, blah. There we go. And then we do value equals 0. And this is self. And then self dot next node equals none. Beautiful. Okay, so in it, do do self dot self dot an empty linked list. Yeah, there we go. That's all we care about, right? And then this would be we'll just say data, right? Let's just call it data. Self dot data equals node, right? We'll return return value of the ith node 0 indexed. If the index is out of bounds, return -1. Okay, so we do this. From unit tests, import test case, class, test, linked list. I'm actually streaming, right? I want to make sure this actually works. Usually get at least one person coming in and saying hi by now. Oh, whatever. Okay, test case. Def test. Linked list class. Test. I don't really care about that. Test get returns. Will return the value of the nth indexed the oath. Returns the value at index n. Value at the provided index. We need to insert. Wait. We'll insert a node with the value at the head of the list, at the tail of the list. Remove. Yeah, so we need to insert. We need to do this, right? So we're going to do pass for now, right? But effectively, this is return stuff, right? So pass here. We need to insert at the head. Insert a node with the value at the head of the list, at the tail of the list. Head of the list is the first, right? Okay, insert head. So this will be temp node equals self dot data. New node equals node. New node dot value equals val. New node dot next node equals temp node. Insert tail. So this is we need to go through this until we get to the tail, right? So we need to go until we get to the tail, right? So we take self dot data dot next node, right? And we iterate over it until we get to the end, right? So while next node is not none, tail node equals none. Um, No, I don't like this. We just want to, well, true. If oops, well, true. True. Uh if next node is none, if self dot data tail node equals self dot data, actually, yeah, no. So if we next node is none, break. Next node uh, next node equals next node dot next node. I think I can get away with just this being node, right? Or current node. There we go. Current node. So here we'll say new node equals node. New node dot value equals val. We're going to move this up to here. If self dot data dot next node is none, self dot data dot next node. Actually, no, I don't like. I don't want to do this because we're about to do this anyways here, right? So self dot. Sorry, not this. Current node dot next node equals new node, and then we break, and then This gives us the last possible node. And we're done. Yeah, there we go. Pass. This needs to be imported. Get values. Interesting. Nice. Okay. Do do insert head adds to adds new node to start of list. Here we do linked list equals from data structures dot singular list linked list linked list. There we do linked list equals linked list, like that. Beautiful. Self dot to do linked list dot insert head val, which will be, we'll say 1 there. And then what we want to do is we want to do another one, head, and we'll make this 10. And then we do self dot assert equal linked list dot data dot value equals 10. Is it the other way around? Is it I can't remember. I'm always forgetting this, like actually forgetting this all the time. I can't remember if it's the beginning or the end that they like. Oh, wait, what? Why is this bad? That's weird. There we go. There we go. Value. We'll say no, because it can, I guess it can be, yeah, there. If self.data dot next node is none, this doesn't actually have to do anything. If self.data is none, self.data equals we'll do this and then val. New node. New node dot next node equals self dot data. Self dot data equals new node. There we go. Insert tail. Do. Data. So insert tail. So we should get 1. And self dot assert equal dot equal linked list dot data dot next node dot value should be 10. And if I do this exact thing here, this should be 1. Did I do insert tail wrong? Oops. 1 sec. Okay, so that is correct, but what's the problem here? So, okay, if self.data int or none. If value is actually no. Yeah, there we go. Int or none. insert at the oh wait, yeah. Dot next node is none. We take this new node and we do self dot data dot next node equals new node. Return. But we should probably just do this. Actually, wait, what's the problem here? Oh, right, because it's none. If data is none. Data equals new node, return. There we go. Okay, so remove the ith node index. If the ith node is out of bounds, return false, otherwise return true. Current index. If index is greater than 0. Sorry. Wait, what's the return type? If index is out of bounds, return false, otherwise return true. If node, if self dot data self dot data is none, is not. If is none, return false. Right. If current, if index, I guess we can make this generic enough that it will just work, right? While true, if current current node, we need a current node. Current node is a node or none equals self dot data. If current node dot next node is none, break. If current index is equal to index, return true, right? But we actually have to do the removal, right? So we have to actually remove this node, right? What we do is we have to temp the node, temp node equals current node, right? And then we do current node dot next node equals temp node, or sorry, we need the previous node. Previous node. Previous node equals none. If current index is equal to index, which I think I'm thinking of, I'm overthinking this a little bit. Okay, so let's see. So we need the previous node so we can replace, right? So remove at index. So if index is equal to 0, then that means remove the first one, right? So self dot data. So we're going to deal with this one first, right? Self dot data, right? This would be the current index. We have our current index of 0, right? So this is where we're currently at, right? How far along we are. Then we need the current node, right? Which is self dot data. We need the previous node, which is none, right? So, or sorry, the next node. So we need to do temp node equals self.data.next node. If temp node is none, return. If self.data. Actually, no, because it doesn't matter. We just do self.data equals self.data.next node. And that will effectively remove that there. There we go. And that's effectively our logic, right? So while true, right? So we can step through it. While true, we take our current index, right? Which is going to be 0. We're going to start at 0. Yes, we're repeating a little bit of information, a little bit of stuff here, but it's effectively just to do that. So we have this is how we're stepping through kind of thing. So all we're doing is if current index is equal to index self dot sorry, not that current node dot previous node dot next node equals current node dot next node. If next node dot if current node dot next node is none, return false. Current node equals current node dot next node. If current node is none, sorry, it's none, break. Return true. if current node dot next node is none, false. Current node equals, previous node equals current node. Current node equals current node dot next node. Okay, so I kind of don't care too much about like actually writing this, like writing tests right now, because like at the end of the day, I'm not even sure if my tests are going to be robust enough. So what we're going to do is we're just going to paste it into here and hit run every time we want to test it. Time limit exceeded. You may have an infinite loop in your code. Yes, I do. There we go. Beautiful. So it's on the remove. I'm assuming it's this one. Let's do this here. No, it's probably the remove. Yeah. Return true. If I just do this, does this prevent the does this prevent the infinite loop? Return an empty list. Run. Insert one. Get values. Insert head. Insert tail. Okay, we're gonna do this. Test case 0. I think this is the test case 0, right? Yeah, it's technically test case 1. Test case 1. Right? We do this. Delete. We do this. To do. Okay, so we do bam. I'm gonna remove this. Okay, so we do linked list dot insert head 1, linked list dot insert tail 2, linked list dot insert head 0, remove 1, and then linked list dot get values, and get values is expected to return this. Oh, these are the expected values. Yeah. Self dot assert equal There we go. And then we can do that. And we run this and we get an infinite loop. Sweet. But let's see where we get our infinite loop. So we just do this. We run it. Oops. We run it. Where is the infinite loop? It's not that. So it's insert tail that's the infinite loop. Or is it the remove? It actually, I think it's the remove. No, it's the insert tail. Okay. I really hate fucking shit. Do. Wait. Okay, so this one works, right? Okay, that works. That's insert head. Insert tail does not work, and it's probably here, right? So if we run this in debug, we can see what's going on here. There. Current node, self.data. So here's current node. There's next node is not none. Oops. Current node dot next node equals none. False. Current node dot next node dot next node. That's a problem. It is straight up supposed to be none. Here's next node. Next node is none by default. Yeah. Like, what the hell? Sorry, current node dot next node is none. False. Yeah, it's always false. What the actual fuck? It's supposed to be. Is it? It's a node. But the next node should be false by default. Like, it should be none. And we're not setting it to anything. Oh, this is why. Self dot. No. Let's do this. This one happens first, right? True. False. True. So this returns back. What's the value? 1. Next node dot value. 1. It's returning itself. Copy. So show copy of the object. Can't remember if this is replace. Returns a deep copy of the object. I feel like no, I feel like a deep copy is probably what we want here. From copy, import deep copy. I know deep copy is not like, deep copy is not really deep copy. Okay, we're going to see if this works. Self.data.next. Self.data. There. Self.data.next node. dot next node. There we go. Yeah, it's the deep copy. I wonder if copy will work though, because deep copy is less like deep copy is harder. Like it's not quite what we want. If we can get away with a copy, copy's lighter. Self dot data dot next node. Self dot data. There we go. That fixes it. Yay! Remove. Get values. While true. We do the current node. If current node dot next node is none. Break. Current values dot append current node dot value. If self dot data is none. What are we doing if it's none? Dot append value. Break. Current node equals current node dot next node. Oh, right. Return values. Zero, 1, 1, 2. Where's the extra 1 coming from? Insert at the head 0. Okay, so that's fine. But how are we getting a double 1? So this is an insert head issue here. How was self.data that? Self.data.value? Where did self.data get 1 from? Yeah, no, it should be. Oh, this is why. Yeah. Do. Yeah. Okay. Now we do that. Here. Oh yeah, yeah. I gotta change that. Yeah, that's my bad. Well, true. If current node dot next node is none, break. There we go. Don't care about that. Do care about this. We're just going to do debug here. Current node dot next node dot value 1. That's not right. I do not want to do a copy here. Data, self.data. Self.data and current node are different. How are they different? Wait, what? Okay. Okay, so do new node there. We do not have it, so we step over, right? We step into self data. These are the same, yes. Okay, so self dot data dot next node dot value. Self dot value. Data dot value. That's not right. Insert head is still wrong. Self dot data dot value. That's wrong. New node dot next node. I found the fucking problem. I found the goddamn problem. I don't think this needs a copy anymore. Yeah. I was like, that's weird. No, you forget to do one return and it fucks everything up. Current node. Okay, so our remove does not actually remove here. If self.data is none, return false. If index is equal to 0, self.data to next node. Return true. Current index is 0. Current node current node equals node or none, self.data, right? Previous node is none because there is no previous node. If current node is none, break. If current node, oh yeah, I forgot to do this. Current index plus equals. Actually, I guess we don't even. Yeah, no, we do. Plus equals 1. Um, do. Previous node dot next node equals none. If current index is greater than is yeah. If current index is none, return false. Yeah, no, that was right. Let me just do this. Here we go. Node. Here's our node, right? We've got our current node. Oh, right. We haven't actually created current node. Current node dot value is 1. It should be 0. It should be 2, shouldn't it? Oh yeah, no. The current node dot next node dot value should be see the first node. So this is insert at the head. So this gives us 1. So we should be 1. This, because this is a tail, we should be 1, 2. Here we should be 0, 1, 2. Self dot data dot current dot value is 1. Oh, I'm in the wrong one. Like, why is this not working? Here. So current node. 0, 1, 2. None. Okay. If current index is none, we return false. Beautiful. If current index equals index, right? So current index should be 0. Yeah. And then index should be 1, right? Beautiful. So these are not indexed. So we continue. Current node. So previous node should be none. Yes. Winning. It's because this isn't this is not correct. That's why. Because we need to be able to insert in between and like essentially like change things. Okay, so previous node dot next node equals current node dot next node. And then current node equals no, actually that's just correct right there. Yeah, no, I think that's right. Yeah, I was right. What's case 2? So insert head 2, get 5. Do we have a get? Oh no, I do have a get. Well, true. If index equals 0, if wait, what's the return values of get? If index is out of bounds, if index current index equals 0, current node equals self dot data. If current node is none, return -1. If current index is equal to index, return current node dot value. Current index plus equals 1. I do 5. Get 5. Wait. How did we get to, like, how did we actually return 2 on get 5? Well, we're definitely going to debug this. Debug. So current node, self.data, beautiful. Step into current node. If current node is null, none, we skip over. Is 5 equal to, is 0 equal to 5? No. No wonder. Current node equals current node dot next node. There we go. Stop. Insert 1, remove 2. Yeah, that makes sense. We break because you can't remove from a value that is none, right? So this should be self dot assert true. Remove true. Oh wait, remove 2. This should be false. Wait. Okay, yeah, it is. It is 0 indexed. Okay, yes. This should return false. Current index. How are we getting this past our current index? Like how are we getting to past our current index here? If current index. So current index is 0. Index is 2. Okay. Current current node is none. Current node is none. Oh, that's why. Okie dokie. Design double-ended queue, which is just a doubly linked list, right? Well, that's a queue. First, so this would be first node, last node. equals value. No. End of the queue. If self dot first node is none, new node. New node equals node value. If self dot first node is none, self dot first node equals new node. Self dot last node equals new node. Uh, do, 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 do. So this is append to the end of the queue. New node. Self dot last node equals new node. Self dot first node. Sorry, new node. We make a new node when we do this. This would be a return. Okay. Then we do self dot first node. Sorry, new node dot next node equals self dot first node. And then self dot first node equals new node. And then self dot length plus equals 1. Removes the value at the end of the queue the queue is empty, return 1. Return -1. If self dot length is equal to -1, return, or sorry, is equal to 0, return -1. Actually, yeah, yeah, yeah. I do not suggest doing this for actual projects, but you know, when you're interviewing, you gotta do the companies end up asking you to do like Leetcode shit, and Leetcode shit is all like build your own libraries that you would never do in real life. Get me wrong, like some of this is actually useful because like depending on the company, some of this is like if you worked for like a company that's like really really large, you might actually implement something like this to like shave fractions of a fraction of a second off of something. Is like, when you're at like Google scale or like Netflix scale or anything like that, like it can actually be like worthwhile. I effectively have this, so we can just do this. Yeah, 100%. I'm totally with you on that one. Return -1. Yeah, effectively like if you're working, you should probably go do that, right? Do 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 do. Like if this is if you're at work and you're writing something like this, you have bigger problems. Oof. Sorry to hear, man. That's never good. But it does happen. Okay, so first things first, we want to do a self.assert true, right? And then this would be self.dq dot is empty. Then self.assert. Then we do self.dq dot. Fuck, I'm just gonna move this into here. It's fine. I'm just born and living in the wrong century. That's all, dude. It's tough out there. How long were you a software dev? And 14. Wait, you were a software dev for 14 years and you're still having trouble finding work? That's crazy. Self dot. Sorry, not self. DQ dot append left. Told you, wrong century. That's so weird. Usually like if you're like if you're there, right? Like if you're at that point, I would expect it not to be that hard for you to necessarily find work because like I guess it depends on where you're living, right? And left 20? No, sorry, pop left. Ugh. Pop left. Pop left. Should be 20. Self dot assert equals. Oh, sorry. Oh yeah, that would understand that would be understandable. Are you okay with sharing what country you live in? See, append 20. I didn't know that Indonesia was a military-driven country. I can definitely see how you're having trouble finding work though. The East, the East really does not like Southeast Asia does not historically treat developers as well as they should. You really want a Western country if you're a developer. I have a friend in Indonesia. She's good people. She's also well, I don't think she's a software dev anymore. She was. She was more researchy based though. I don't know what she was doing exactly. She's another streamer though. I'm aiming Japan primarily, but Australia probably a good idea too. You should I know that not everybody likes it, but like if you can, you should aim for the States. Like I'm just gonna be honest. If you can, aim for the States. They're honestly like your greatest bet. Your English is good enough. Oh, I know that I know that feeling. I can't work in the States either. It's not gonna happen. Let's see here. Is empty append 10 is empty. Append left 20. If you can get into a European country, then it will make it easier to get into the States. It also depends. Like, do you have a bachelor's degree? Ooh, you should check for Canada, dude. Try for Canada. Specifically, look at Vancouver and Toronto. Yeah, you want to look at if you want to try for Canada, look for Vancouver, Toronto, and Montreal. Although Montreal is going to want you to learn French, and Canada is still really easy to get into. Yeah, we have a lot of programs that you could probably take advantage of to get over here. And then once you're over here, you know, like it shouldn't be too difficult for somebody with your experience to find work. Yeah, this is like my first time doing Leetcode too. So these are things that I understand how they work, but like I've never actually implemented them myself. Because fuck that in day-to-day life, right? My biggest mistake is not having LinkedIn for a long time. I just made it like a year ago because of unemployment. So I'm so used to applying offline. It seems not standard nowadays. It is not. You want to get hit by. All right, so it's different everywhere, but like in my so I live in Canada, right? So my in Canada, you want to get hit by the recruiters. You don't want to reach out to recruiters. So like I didn't apply for the job that I'm interviewing for right now. I'm a recruiter reached out to me and I said, "Sure, I'll interview." And that's just how it works. There's I've had a couple interviews this month. None of them are really going anywhere. So this one seems the most promising, so I'll just continue with it. So is empty, append is empty, append left. Do wait. Append left 20. Okay. Yeah. It's to do. So my list here should be 10. So now so if I append left, it should be 20, 10. Then if I pop here, we should be, oops, this should be 10. Pop left, we should be 10. Oops. Oh, thanks for the follow, man. I do warn you that normally I am I'm programming. I'm doing like I'm doing a lot of C# with Unity right now in my free time. But like right now because I'm prepping for interviews, I'm just doing Leetcode. But my primary languages at the moment are C# and Elixir. Python's just something like if I'm going to do an interview test, I'm going to do it in Python because I've been programming in Python for way too long. So now I should have an empty list here when I do the no, this should pop 10, so I should return back to this. So this should be 10, right? And then we do another pop, and this should be, I think, -1 is what they said. Yeah, return -1. -1. And then when we do another pop, we should return -1. And then we do an append, dq dot append 30. Right? And then this should take our list to 30. And then we do a pop here, and this should be 30. And then we do the true, and this should be empty. A main language is just like whatever your like whatever language you use the most, right? Oops. So like whatever language you're the most comfortable in. Like if I gave you a project, right? A super generic project and you could program it in any language, what language is that going to be? Like if the answer is C++, like if the first language you reach for is C++, then your main language is C++, right? It's the idea, right? Unless you're working. Like if we're talking about your free time, right? Free time, your primary language is whatever the fuck you want it to be. And if you're working, your primary language is what if when you go in and clock into work, what language are you developing in today, right? Or like if you had to divvy up, like if you're programming in 4 different languages at work, right? Or 3 different languages at work, right? So say that like I'm working on an application that if I can choose freely, C. Okay, yeah. So your main language is C, right? When you go to work though, like when you're working and somebody asks you what your primary language is, that's just going to be like whatever you spend the most time in at work. Like, and then like your secondary language is going to be like whatever you do the what next, right? But yeah, your right now your primary language is C, right? But yeah, it's just relative to like whatever you're programming the most into, or like what's your favorite language, stuff like that. When do I get to say my primary language is no longer JavaScript? I don't know, man. Don, like, uh, wow Tech, do you know Wow Tech? Do you know Don the developer? Also, sup Don. Shout out. Shout out. Oh, I did this. Shout out at Don the developer. Hey, I hope you're doing well. I'm doing okay. I'm practicing for frickin' interview that I have next week. They want me to do some Leetcode shit, and it's like gonna be the first time that I actually care about a Leetcode test. I have turned down offers because they wanted me to do Leetcode, and I'm just like, I'm not doing that. I really don't like Leetcode. But whatever. We do what we can when it's required. It's an interesting company, and I hear good things about them from people that use their software. So we're going to rebuild this entirely from the ground up here because I did this entire thing around like, oh no, this is the single A list linked list. Yeah, here we go. Append. Okay, so where did we pop left? That's what we wanted. Okay, so we have append, right? So, oh, here, this is a great example. This is a great time for me to show you what I mean by like debuggers are amazing. Now that I'm in Python, we can actually get there. Append 20. We go append left. There we go. And then if we run this in a debugger, we should hit there. So here's our first append. Our value is 10. We can see our value right there, right? So we're going to create a new node here with the value of 10. Here's our new node, and we can see the structure. And then if our first node is none, we're just going to say this is the first and last node, and then we're going to, this should just equal 1. So I'm just going to step over this, and because I want to be able to continue here, we're going to do self dot length equals 1 there. Now self length is equal to 1. So if I go here, we can see that it's 1 instead of it being 0. Then we can come down here and now we're at the append left, right? and is empty, append left. Oh, I did a pop left before an append left. Oh no, there's the append left. Yeah, okay, so we're there. But we can also jump to here. See, we can jump to 18. So there's where we came from. This is where we're going. So here we can jump over to this. We see this. Beautiful. So see, if self dot first node is none, is it none? It is not. So we're going to jump over that if statement. And then we're going to replace the first node with the new node. But after we give new node a value of next node. Sorry, new. So we can take a look at what new node is right now, dot next node, right, is empty. And we can say the value here should be 20. It's 20, right? There we go. So then if I go here, and now we can see that next node is there. And then if I do dot value, this should be, I think, 10. Yeah. There we go. And then the next node on this one should be null or none. Well, I didn't. So I'm using the default code that they provide. And initially I just did it using an actual list on the internals because I was like, whatever. And then I was like, you know what? I guess a queue is like this should probably just be a doubly linked list. Mainly because like I hit the solution because I was curious after I got it working, which took me like no time. And they were using a node, and I was like, you know, that's a good idea. Let's switch it. I could probably use the practice. It's been a little bit since I've done too much of this, right? Okay, so we are currently on line 62, right? So here, if we do self dot length, we should be 1. There. Which one did we do? So pop left did not work. Oh yeah, it's probably because I didn't implement it yet. Okay, so pop left. So this works here. So pop left. If self dot length is less than 0, return -1. Yeah. So I've got to essentially run their code, their interface. So I don't get to pick the names anyways because I don't like this. Like Python, you don't do that either. You do, but he's got them all squished together, and like is empty is differently cased than append left. It's so weird. Sorry, is equal to -1, return -1. Okay, so pop left. So we want to pop the first one. So if self dot first node is equal to is none, return -1. Then we do self dot to do temp value equals self dot first node dot value, return temp value. But then we need to replace the first node. Self dot first node equals self dot first node dot next node. And then this one pops the end, right? So we effectively do the exact same thing. Turn -1. Okay, so here, if self dot first node is none, return -1. Self dot, so this would be temp value equals self dot last node dot value, right? Oops, not none. Node. Whatever. It doesn't matter. No, I didn't mean to close it. Return -1. Let's see where we got into trouble here. Yeah. Okay. This works then. Beautiful. Temp value. So this should now complete. Just give me a second here. Look. And then if I jump to this, yeah, there we go. We got the good goods. Okay, so temp value. And then we need to replace the last node. If self dot last node I forgot to check for last node. Yeah, this is going to be an error here. I'll deal with that after I finish this here. So if self okay. So that means that we need, for popping the last node, we need a link to the previous node. So when we append new node, this is appending to the end. That's next node. Self dot, sorry, not self, new node dot next dot previous node equals self dot last node dot self dot last node. Yeah, okay. Sorry. If self dot first node is none, we just we bail out. Or sorry, we seed it. There. New node dot next node equals self. Okay, so the new node, so we're pending left. We're pending at the beginning, right? The next node will be the first node. And self, which means that we need to cache the self dot first node dot previous node equals new node there. And then this will be next node. And then this will be first node equals new node. Yeah. And then pop we're doing from the very beginning. First node is negative, is none. We give -1. Yeah, Don? Temp value is the index. Actually, we should just say temp node. Temp node. Let's do. You just reminded me how much I hate Leetcode. I think I may skip that section in boot.dev. You're welcome. Yeah, I'm not a fan. Temp node dot value. Okay. Yeah, no, yeah. Okay. Where was I? Okay, so if first node is none, if self dot first node is equal to self dot last node. Self dot first node equals none. Self dot temp node equals self dot first node. Last node equals none. Return temp node dot value. Temp node. We get the last node, and then we do we need to make a new node. Oh no, we don't need to make a new node. So self dot last node dot next node equals none. Self dot last node equals next. So last node, we grab the previous node and then we do that. And then last node equals self dot last node dot previous node. And then we return that there. And append shift here. Append left. Yeah, this covers everything for left, and this covers everything for right. And this deals with that. We no longer have a next node. Do previous node. And we return the value. And then I think that should just do this, right? Yeah, that worked. I do not think that this is done. Sup, Road to Environment Artist? Submit. Let's see if that worked. Oh, it did work. Let's see what the solution was. Yeah, that's probably the right thing to do. Head and tail instead of first and last. Yeah, that makes sense. They had a little, like, technically what I was doing with the null values would probably, it does make sense. This being -1 though, this gives you the false sense of accomplishment. No, this is, I don't think that you should do this because now you can't have values greater than that are well, actually, I guess if you're only ever using a positive integer, this makes sense. Whatever. Design a binary search tree. Are we still in data structures? Okay, yeah, we're still in data structures. Design a binary search tree. Fuck, I can't remember the names. I can't remember what the names of these were. It was leaf and binary search tree. What was it? It was leaf. Do yeah, for finding a leaf node. What are the names? Do verbiage. Binary tree. Binary tree verbiage. Verbiage. Say root. Oh yeah, it's a root. Okay, there we go. So if I'm not mistaken, it's the root is the first one. Or the root. Edges, links, or links from the top. A single node as a root node. Tree whose root node has two subtrees. Binary trees. Yeah. Okay. So we'll use we'll just use this. Okay, so class leaf. So we need to be able to insert. So we need a self dot root equals none. So node will have a left and a right. Left. So definite self dot right, self dot left. Self dot value. There we go. So insert if self dot root is none, self dot root equals wait, a key value. We'll design a map which has integer key to integer value or tree. Your tree class should support the following operations. We'll map the key to the value. Oh, okay. We're just we're making a map. To key. So self dot key equals key. Tree map. It's a nested rectangle? Tree map is a visual method for displaying. Because like, yeah, no, this is totally this, right? Node, and then we do key value. Oh, it's val, not value. That's why. Silly me. Um, uh, while true, if self dot root dot value is greater than val, is there more details about how this is going to work? Oh, right. 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 We're going for the key. The key is the real thing and the value is the fake thing. Is effectively like the counter, right? We'll map the key to the value and insert it into the tree. We'll return a value mapped. We'll initialize a binary tree to do. We'll map a key to the value and insert it into the tree. We'll return the value mapped to the key. If the key is not present in the tree, return -1. We'll return the value mapped to the smallest key in the tree. If the tree is empty, return -1. We'll return the value mapped to the largest key in the tree. If the tree is empty, return -1. Move. We'll remove the key value pair with the given key from the tree. Okay, so we're not actually doing any math here, which is weird because you would imagine that like whatever. Key value. Well, true. If root key is greater than value is greater than key, current node equals self dot root. So if current node dot uh, dot left is none and current node dot right is none, return, or sorry, this one's a little bit more tricky. Sorry, give me a second here. Let me get like a baseline fucking freaking done here. Okay, so we would do if current node is none, new node equals node key val. New node, return. Current node. Oh, wait. No, yeah. If current node dot key is greater than if the current node's key is greater than the key, then we're going to go left. And if key is, I'm going to do this because this maps to my head a bit better. So if the key is less than the current node's key, we're going to go left, and if it's greater than, we're going to go right. Current node dot left else current node equals current node dot right. If current node is none, there. So what we're going to do is we're just going to always take this. We're going to update the parent node. There we go. There. So new node dot parent equals parent node. There. And parent node dot if parent node dot key is if key is less than parent node dot key, then we're going to go to the left. Parent node dot left equals new node. Else parent node dot right equals new node. I can insert. Okay, so what we're going to do, now this is going to give us this case here. Ooh, it gave us two cases. So now we can do this. What did we call it? Tree map. Do. There, and then we're going to do insert. Get one. Get min. I think this should return 1. Do you know what the funny thing is? I could totally like go through I could go through this and have the fastest possible test case by just returning the values that they want. But that would be bad because then we don't actually do the work, and doing the work is important. Hmm. Okay, so we do insert 1, 2, then we're going to do an insert 4, 2, insert 3, 7. Insert 2, 1. Wait, get ignored keys? Interesting. I'm going to start with this one. the fuck? Oh, yeah. There we go. This is what we care about the most right here. Bam. Nope. There we go. Do that explains the leafiness. So like I guess this was the branch and then we have the leaf. I think I kind of get why we might want to just not have all of that. Like we might just want to do. We should probably let's keep this with node and then we'll do the logic in here. Dot is leaf. No, no. This makes sense. So insert. We do parent node is none. So parent node is none. So that's the parent. Then the current node is self.root by default. So if current node is none, if current node is none, wait, how did we get there? Because parent node should be the root node in this case, right? Like we shouldn't be able to hit that at all. Current node, parent node, beautiful. So current node is not none, so we skip over that. Then the key is 4, And if we go to current node, key is 1. So we're going to go right. Oh, that's why. That's right. I did that in the wrong order. If current node is none, if current node dot key, if key is less than current node dot key, if key is equal to current node dot key, return current node dot value. If current node dot key is less than if key is less than current node dot key, then we do current node dot left equals current node equals current node dot left. Else current and then continue. Current node dot equals current node dot right. What? Wait, where did we? Oh, yeah, okay. Get min. Self while true, current node equals self dot root. If current node dot left is none. If self let me go up to here, get min. Return 1. If self dot root is none, return -1. Current node dot right is none, and current node dot left is none. Return -1. If current node dot wait. If current node dot right is not none, node return value. Return value. Current node if current node dot right and current node dot left is none. Is none. Break. If current node dot left is none, return value equals current node dot key. If current node equals current node dot left. Current node key is 1. Oh, that's why I forgot to return. Return Oh, that's why. Okay, beautiful. All right, so let's grab. Did this have any other ones, or was it just one? No, it was two. You can get max. Oh, I don't have a get max on this one. Okay, insert get one. What's up, Mecca? One sec. Get one is going to return two. Insert. Yeah, there's my insert, and then get max. Okay. I'm doing one of the worst things ever. It's called Leetcode. Yeah. Current node equals self dot root. Current node. Oh, I forgot to check this. Wait. It's get min is. Oh yeah. It's the key. Return the key. Oh no, yeah, here. Never mind. I did do that. Okay, I was just fucking slowly going insane here. Current node dot left. Sorry, dot right is none. Value equals current node dot key. Break. Return value. Current node equals current node dot right. Right, because I think the max, min and max are supposed to be like, give me a sec. Yeah, I get the smallest key. Get the largest key, which would be 4, not 0. There we go. And this one ignored keys. Return an array of keys in the tree in ascending order. Return an array of keys in the tree in ascending order. Oh, in ordered keys. Okay. I was totally adding I was adding characters there for some stupid reason. So this here should return an ordered list of the keys. So if I do self.assert equal, we should have, what is it? 1, 2, 3, 4. And then if we remove 1, we should do self.assert equal. And this should be 2, 3, 4. And this should return, yeah, this should error because we're not actually doing that. Current node equals if self.root node is none, return an empty list. Current node equals self.root. In the instructions, they effectively told me bring a laptop with your environment installed on it and make sure that you're not allowed to use ChatGPT or AI coding stuff. We want to see you work. And it's like, isn't that kind of a given? Like, why does that have to be something they ask? Oh, true. Yeah, it can be. It mostly is because like um during an interview, the idea is to get you, like personally you, to demo something, right? Like, so the idea is that, hey, you need to show us that you can do this, right? And if I give you an unfamiliar environment, then you're now crippled by our environment that we've set up. So you end up in a situation where it's just like, well, if we're going to expect you to program something and you're not going to be able to do it because like you're going to get slowed down by the environment, then that's not fair to you. Like we'd have to like then adjust for that. But if we let you bring a laptop and do the programming on your own laptop, then you can do it in an environment that you're already familiar with, and then there's not really an issue there. Like you just do you, right? And if you can't do it on your own system, like we're in an environment that you're familiar with, you have bigger problems. Give me 1 sec. I'll be right back. I'm gonna grab some water and grab food. Okie dokie, I'm back. Or what? When was this message sent? Oh, a great old big bottle, a glass of piss. No, I'm just kidding. It's 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 Gatorade. I have the Gatorade powder, and I just mix it with some water. And for food, I'm having some beef with some broccoli and onion, and I've mixed in some chili oil. What's chili oil? Give me one sec. Okay, sorry. My girlfriend came home and she brought home some ketchup Cheetos. Uh, for anybody who's not in Canada, ketchup chips are a thing in Canada. So I think chili oil predominantly like started in China. But don't hold me to that. I could be wrong. I'll be right back. So what it is like this is closer to what I'm eating. So it's like you chop up chilies and lots of seeds and chili flakes and stuff like that, and it all goes in and makes a chili oil. You can close it, but it's just adds spice. Sorry, I just had to go make my girlfriend's day by giving her some really good news. She's been applying for a job. She applied for a job and um, she thought she fucked it up, but they just I'm one of her references because I'm her manager at one of the companies that she's worked at. Um, so uh, I'm listed as a reference. So they emailed me. I just got the email as I was sitting down. Yeah, manager. I was the lead of her department, the department that she worked in. Yes, yes, people actually contact references. I have been her reference for multiple different companies. I've been multiple different people's references because I have been a manager before. So my favorite question is because you usually like what you managed. I managed I managed a department for a company that did they did a lot of things, but their primary focus was like dance instruction. The company was one of my friends play he's my friend now. I didn't know him at the time when I started with the company. But so this guy here, right? He's a friend of mine. And he him and his ex-wife did ran a dance company together. It was predominantly a dance company, but they he's a very entrepreneurial guy. So he's branched out into a lot of different things over the years. And I used to build all of his backends, but he was branching out into like building websites for other people. So we brought on some people, and I was in charge of managing them because like I maintained all their servers and their DNS records and all the routing and stuff like that for all of that, and built out all of their backends and everything like that. I managed that. So I also ended up just having to manage like all the different teams. So um not all the different teams, but I had to manage the development team. So anyways, so I did that. And we brought on a couple other people, and my girlfriend was one of them. Uh, his most recent entrepreneurial thing is he's doing real estate now in New York. And then this is his wife right now, his current wife. Um, I think she was pregnant in that photo because they had a baby recently, or somewhat recently. Oh, I didn't know that she was like a reoccurring character on this one. Oh, that's cool. Good for her. I haven't met her yet. Um, just because like I haven't seen him since COVID, since like mid COVID. But yeah, I was his guarantor when he got his Canadian passport for the first time. Hmm. He was born in the States, and his ex-wife was Canadian, and he was living in Canada for a number of years. Um, I think pretty much until All Rise started. Anyways, so he got his Canadian citizenship, and when he went to get his Canadian passport, he needed somebody with a Canadian passport that with a current Canadian passport that he had known for a certain number of years, and I fell into that category. So I signed I signed his guarantor. I was his guarantor. Hmm. It was really cool though. He was my favorite actor on one of the TV shows that I really liked, which was Travelers. And I got to go to like an after party that he hosted for Travelers and his local friends. So I got to meet Eric McCormick and Nesta Cooper. Um, let's see. I want to say that Jennifer Spence was there as well. Mm, but I don't remember exactly who all was there from the show. It was too many years ago. And And Jay was my favorite actor. I got to meet a couple of the main cast. I got to meet I got to meet one of the writers. I think it actually might have been Brad White. Yeah. No, it was really cool. Um I know. He's like actually a super nice person in real life. And he played such a piece of shit so convincingly on Travelers. Like in Travelers, the first time you meet him, he's drunk. Like he's a drunk police officer in like the first episode. And he barges into his baby mama's house and gets mad at her, backhands her, and she smashes her head against the counter and dies. And he fucking just pieces out. And that's his introduction in well, and this was the woman that he killed in the first episode. She was great in C. But yeah, in the first episode, he backhands her, and she smashes her face against the counter and dies. Hmm. Did I say it wrong? Mm. Yeah. Jennifer Spencer. I really liked her character in this as well. I really liked her in this one. All right, I'll be right back. Mm. Um, So how do I apply for jobs? I go on LinkedIn and I change my status to from not looking to work to looking for work. And then a recruiter will reach out to me and I will say, "Hey, I'm interested in interviewing." And then I will interview and I may or may not get that job. And that's how I look for work. Yep. Okay, so I think I've effectively hit the point where it makes sense to restructure this data structure. Because right now I don't really have a way of doing like grabbing a left and right. Although I probably could because I have to traverse the now I have to traverse the tree differently. Hmm. Getting all of the stuff in order is actually kind of a pain in the ass. I didn't really think about that. Yep. I've filled out a couple of things manually, but I don't usually end up getting many interviews that way. So so the thing is that I come from a time, right? So like I started development when it was easier to get hired than it is now, right? And I worked really hard to get hired and I got hired. And then I worked for a number of years in software development. And now that I've worked those number of years, it means that I don't look for work the same way because recruiters will reach out to me because I have experience. And like I'll get contacted for senior roles and I get contacted for senior and intermediate roles, right? So since everybody's looking for seniors and intermediates, I get contacted because of that. So okay. So I don't think I've gotta do. I need to like effectively. I need to just flatten this out. Hmm. Actually, I haven't. Hmm. So I can do effectively bubble sort this way. Yeah, no, I think we just do this, right? And then we pass in the list. There. And then we do this. We do let's do this really quickly. I just gotta check something. No, not terminal. I need a Python console. It's going not good. I'm not bad. Not bad was the right answer, not the wrong answer. Freudian slip, maybe. I am doing Leetcode, so you know. Hmm. Index error. Which question is this? Let's just build a binary search tree. Mm. Ugh, sorry. I'm trying to avoid. I'm debating whether or not to avoid doing index access. Like, do I want to do? Because like this would be slow, right? If I do a length and I do, if I do like my list length and I do total index, like total count. This gets really expensive. So maybe I don't want to do that. But I have an idea. Because I will know how many are in here, right? So if I do this, self dot count equals 0. And then when we do an insert, hmm, get min max do, and then remove will do a self dot count minus equals 1. There we go. If self dot count is greater than 0 is equal to 0. Mm. Actually, no, we can't get here without that. There we go. All right, so we can't reasonably get to a point where this is going to happen. Okay, so well, true, right? Here we do current key equals index. If current key is less than key, my list dot, um, fuck, what was it? Python list insert was insert, right? Insert. If I'm not mistaken, insert is not going to override the value. I think it just pushes, right? Hmm. What's the order here? Index of 1, and we're going to add in 3. Yeah, it did exactly what I thought it was going to do. Sorry, self dot count. Actually, no, I can do 0. We can go from left to right, right? So we're just doing effectively like a quick bubble sort. So we grab that index, current key. Last key. Last key equals -1. Sorry, none. So if current key is less than key and last key is none, or mm, I believe that should work, but I want to test it. So we'll do 1, 3, 7, 10. There we go. And then 4. And then what we'll do is we'll do tree map. We'll say key of 2. Oh yeah, that's why. How are you doing to get today, Apu TT? Okay. So why is it not inserting when it's supposed to be? We got the exact same thing that we passed in. So what we're going to do is we're going to go like that, and then we are going to come into here, and we're going to do debug. Okay, last key is 0 index. Okay. So if current key is less than and oh right, we can simplify this. Key is greater than or less. There we go. Yay! There we go. Now where are we? Wait, what? What's up, Mr. Don? Okay, so how did we get that out of order like this? So my key is 2. My last key is 1. So my list is 1, 3 to do, right? So we do this. Okay, there's current key. So last key is 0. Current key, like the key I'm looking for is 2. And my current key is 1. So if current key is less than key and key is greater than last key, then we do this and we do it. Bam. And then we then we forget to do this, and that's why shit broken. Bam, bam. There, and then there. Huh. Wait. So could you use the internet during your interview? You should be able to. It's rare that you can't. It's more likely that you can't use, like, if you can't use the internet during your interview, chances are that you're probably doing like a whiteboard thing. And at that point, it doesn't matter if your code functions, it matters that you've got the concept, right? Yeah, I prefer whiteboard interviews too. I think that this is the wrong way to solve this problem, to be honest. So I think the way to solve this problem is to go down the left and then trail back up the. I think the way that you're supposed to do this, and I might be wrong, but I think the way that you do this is you go like this, right? So here you've got your root, right? And then you've got like your branches and your leaves. Give me a second. I'm gonna draw all the things after. So like that goes to there and then there and then there there. I don't think that's quite what I was thinking of when I was doing this, but whatever. Right? So if this is like 5, these go down, right? So like this would be 4 and this could be 6, right? So you get the idea, right? But because this has 2 nodes, it means that this here should probably be this is 6, this is 7, and this is 8, right? So if that's this wouldn't be that sorry, that wouldn't be 4, right? This would be 4. This here would be 3. This would be 2. This would be 1. This would be -1. And then this would be oh sorry, no. This would be 0. Sorry. And this would be -1. So you see how that works? So I think the idea is that you go all the way down the left and then you walk back up the right. But another way to do it is to like is to go I don't think this would work as well because like if I go down and branch go this way and this way, then I'm going to get out of order, right? But if I walk the tree up and then down, then we should if I walk all the way to the um this is not a good way to do this. Well, true, right? But the idea would be to go all the way down. Well, true. Leftmost node. Def get leftmost node. What's the complaint here? Oh, that's why I'm indented too far. Um, so this means we just have to walk down. It's not the most performant way to do this, but if current node is none, return ordered keys. Hmm. How do I want to do this? God damn it. Get leftmost node. We walk down the left node. So we start at the left node and then sorry, I'm just thinking. Because the idea of this is that we don't want to create a lot of lists. I'm kind of tempted just to look at the answer right now, just to like get a better idea here. Okay, so we know that we start at root, and then here for every time that we walk this, we want to do a left and a right. Left node equals, or sorry, next left node, next right node. This is actually like it's not a difficult thing. I just gotta think about it. Dot. This one's left, and this one's right. If next left node is none, is not none. No, is none. Right? Then we do keys dot append. No, you know what? I think I was right. Yeah, no. Current node is get leftmost node. Yeah, because if we start anywhere else, we end up fucking ourselves, right? Do. And then while true. So we're at the leftmost node here, right? Let's see if this actually returns what we want. And this should return 1. Of course, we're breaking on. Oh, right. I forgot to do this. Sorry, key. There we go. Okay. Beautiful. Hmm. So if the left node is none, then we know that this is the smallest key that we can currently get to, right? Then we do that. If current node dot right is not none, we do ordered keys dot append current node dot no. Sorry. We do current node equals current node dot right. if current node wait. This needs to be an else. No, we're walking up. One sec. Let me just think about this for a second. So we're walking down, right? So if we walk down the left, right? With this in mind, right? We can do if current node dot left is none, we do ordered keys okay, so if current node dot left is none, yeah, but this would also be, so this one here would give none too, right? Because this is going nowhere, and this one goes nowhere. Sorry, and this one goes nowhere. So this is our starting point. Sorry, this is our starting point. So if we come back up this way, we have to go boom, boom. And then that takes us to do. We go, okay, so if we come down to, so we go from here, we go left. There's 2, 3, 4. It's 4 to do. Oh, I don't, I'm going to take a quick look.
Now let's move on to probably the most
Wait.
I've solved a lot of leak. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem binary search. We're given an array of integers nums, which are going to be sorted in ascending order, and we're also given a target integer that we're going to look for. If the target exists in the array, then we can return the index of it. If it does not exist, then we return 1. The goal is to create an efficient algorithm that can run in log n time. So what algorithm are we going to use? Well, the problem pretty much tells you binary search. So while this is self-explanatory and a pretty basic algorithm, I still think it's really important because a lot of problems kind of extend the idea of binary search and then make it even harder. And this is
Having solved more than 1,500 Leetcode problems, if there is one thing I've learned, is this.
Hey everyone, welcome back, and let's similarly, it's not the target, so we've only eliminated one possibility if you were doing it in your sleep. So I'll try to explain this quickly, but also in a beginner-friendly way. So the input array is sorted. The target value could exist anywhere in this array, or it might not exist at all. When we start, we are considering the entire input array. How are we going to do that? Well, we're going to have 2 pointers. One pointer is going to be at the leftmost index, which is initially index 0. Another pointer is going to be at the rightmost index. These pointers mean that we are considering the entire range. Now, if we could only look at one of these values, which one should we look at? Should we look at the leftmost? If we do that and we see that it's not equal to the target, then we've only eliminated one possibility, and we still have to search all of these. If we look at the rightmost, similarly, it's not the target, so we've only eliminated one possibility. We still have to look at the rest of them. But if we look at the midway point, and technically either of these could be the midway point, the way we calculate it, though, is going to be literally take.
That's not actually what I wanted to do.
Hey everyone, welcome back, and let's write some more Neat code today, solving validate binary search. A very good question for practicing binary search tree questions. We're just given a root of a binary search tree, and we just want to determine, is it a valid binary search tree or not? And from learning data structures and algorithms, you might know that a valid binary search tree is such that we have a node like 2, and every single node in the left subtree, 1, and if it possibly had other children, is going to be less than 2, right? So 1 is going to be less than 2. And similarly, every single value in the right subtree, 3, including 3's potential children, if it had any, are going to be greater than 2. Not greater or equal, strictly greater. And we know this is a recursive definition, so if we had 3 and it had some children, like 5 and maybe 4 over here, we see that it's not a binary search tree because 4 should be less than 3. 4 should be less than 3, but it's not, so this is not a binary search tree. So we need to do a recursive depth first search to solve this problem, but let me show you what you might try. You might just try a simple solution like a 5. We have 5 as the root. Let's check its child. Okay, 3 is less than 5. That's good. Okay, let's check the right child. Okay, 7 is greater than 5. That's good, right? Okay, now let's check 7 because we see 3, it doesn't have any children. That's good for us. We don't have to check anything, but 7 has a left child. It has 4 as a left child. Well, that's good. 4 is less than 7, and it has a right child, 8. That's good. 8 is greater than 7. So is this a binary search tree? The answer is no, because it's really easy to miss. We have a 5 as the root, we have a right subtree over here, and we have a 4 in the right subtree. But we know 5 is not less than 4. That's not true. So we need a better algorithm, and it requires depth first search. We can't just check the neighbors. So a brute force approach would be for...
That's not the one that I'm looking for. I'm wanting to do, okay, there's names that make, there's names to make the nodes to make this easier. And I think that it's like, there's a way to walk this. Current nodes left subtree. Well, not. Mm-hmm. Right here. Yeah, it's effectively, I'm going the other way because I want E to be in the first in the thing, right? Oh, yeah, that's not what I wanted. Any of the values. Okay, yeah. All right, well, I'm in the right. Okay, so current node left is none, right? That means that the current key has to be greater than it has to be the current key, right? So like if this was my last here. So if I have no right, then this is the smallest key that I can currently have access to. And if I go this way, then I get a 4, right? So if to do, then we do ordered keys dot append current node dot key. Now the only problem there is that now if I go right, when I come back up, I need to, oh wait, no. No. I still need to, sorry, I'm just thinking. Okay, so let's see here. Current node left is none. Then we can do ordered keys dot append current node dot key. So there, we've verified that there's no left. If current node dot right is none, current node dot parent. If current node is none, break. Return keys. So we're going to start by going down the left side, and then we'll effectively come up, right? I shouldn't. Should I do this now or should I do this on the way back? No, I think I should do this on the way up. So, okay, wait, one sec. No, because if I do it on the way up, they'll be out of order. If current left is none, we add the key. Wait. Okay, so we're appending no matter what, right? If current left and current node dot right is none, ordered keys dot append current node dot key. Right? So this is the case of like a leaf node, right? So this is a leaf, effectively. And then we do current node equals current node dot parent. If, and then this is continue. If current node dot left current node dot parent. Okay, so this is the very bottom of the list, or the tree, right? And then we go up one, and when we get to when we have the parent, mm, if current node dot left Oh, okay, wait. Right, this is just traversing the right side now? If current node dot left is none. Yeah, no. Okay, we append, right? And then we do current node equals current node dot left. If current node dot, and then we continue. Current node dot right is none. Ordered keys dot append current node dot key. Current node dot current current node equals current node dot parent. Continue. This doesn't really end up working. because now we go, so we come down, we check, both are null, so we go back up. And then when we check, the left and right are, right? This is best done in recursively, if I'm not mistaken. So you can isolate it. Yeah, I think we just. Oh, I'll be right off. Be right back. Sorry about that. I think I'm gonna call it a day and take a break. All right, I will catch you all later. See you tomorrow. Ta ta for now.